Um, this talk's Beyond the PIL, Alternative Image Processing in Python. Basically, Eric kind of shanghaied me into helping out with the conference a lot this year, and I kind of felt bad that I wasn't actually presenting, so I tossed a presentation in, and I had a lot of grandiose plans for this, and they didn't come to fruition because I spent so much time doing some other stuff. But basically, what I did kind of find out was when you go beyond the PIL, it's almost like going beyond the pale. A lot of stuff just sort of doesn't work nicely the way that you would expect it to. So a little about me. I work in software for a large printing company, so it's a lot of graphic processing of images. And I've been doing that for about 10 years, and I work a lot with other vendor systems that are called digital asset management systems. Basically, giant repositories for images backed by database. It lets retailers, catalogers, whatever, throw all this stuff into a web application and go searching for it later. The first project I did for this, actually, I didn't do any coding on. I was the project manager for it, and we scanned the entire back catalog of every photograph that Ralph Lauren Company took from like '74 to 2002, and stuck it in a giant database system. So, end of 2010, I found myself jobless for a couple of months, and I started noodling around with, could you build a damn system in Python? And it actually, everything pretty much was there with the various content management frameworks. Pick one. You know, Django, Flask, TurboGears, it didn't matter. The one thing that fell short was image processing, which, I mean, we've got the PIL, and it's actually really great for what it does. The problem is, when you're trying to use it for the kind of stuff that we do for print production, there's some things that are missing. Image formats. We deal with a lot of raw camera formats, and the PIL doesn't deal with that very well. There's a lot of plugins for some of the other larger open source libraries. And if you're not familiar with RAW, everybody kind of loosely thinks it's a specific format, but really what RAW is every camera manufacturer has their own format. So it's a real pain to kind of deal with all the different formats, and some of the larger libraries, people have written plugins for them that don't exist for the imaging library. ICC profiling, we're off a little bit here. That's another thing that tends to be missing. Basically what ICC profiling lets you do is target your output device so you can do some color management. So typically, if you've got an image, and you've probably all seen this, if you look at something online and you buy it and it shows up, it's not the same color. And that just has to do with differences between outputs for monitors and different types of print media. So ICC profiles basically try to correct for that. And there's a couple different things you can do with them. You can use them to try and sort of, given a source image and a target that's got a smaller gamut, you can just sort of adapt it as best as possible for how it looks. Another thing that we use it often for in print is we deliberately distort the image to try and match a future output. So if you just look at a file on the monitor, a photograph, it'll look a lot brighter and more saturated than when you print that out. Now, if you actually want to know what it's going to look like when you print it, because you're tweaking the colors, then you can use the profiles to try and see what this thing will look like when it goes out on a printing press. Better TIFF support. The TIFF format is a raster image format that a company called Aldus invented, and then Adobe bought Aldus, and they sort of became the owner of TIFF. And it's not used a whole lot outside of printing these days, but there are a lot of printing companies, ad agencies, that have huge back catalogs in the format, and they're real comfortable with it, so they actually tend to continue to use it. At my current work, we have a magazine publisher that still, everything that we do for them gets returned as a CMYK TIFF file. And a lot of those actually use LZW compression, and that's the one thing that's missing from the PIL that prevents you from doing TIFFs. If you use the LZW compression option, the PIL will read the files, but you can't write them back out. You have to write them out as uncompressed. Oops, wrong way. And better PDF PostScript support. Just basically, the libraries that we use most often, Imagemagick and Graphicsmagick, can tie into GoScript. So pretty much anything that you could do on a real Adobe RIP, you can plow through this thing. So we get a lot of PDF files that are really object PDF files that came out of Illustrator or InDesign, or weird packaging applications that you've never heard of. And we need to make thumbnails for systems for these. So all this was sort of me noodling around a little bit, saying some of the stuff that we're doing at work in these other applications, you know, could I make it work in Python? And the first thing I have to say is actually what I found out is use the PIL. In other words, if you don't have one of these needs, just use a Python imaging library. It's a lot simpler and it's a lot saner. And then I'm going to talk about the one bright spot in all this, which is Wand. Wand is an API to Imagemagick, and Imagemagick is probably the most popular engine out there for doing batch image manipulation or library image manipulation. If you're not familiar with them, they come with both a very comprehensive command line interface. So just about anything you can do with them, you can do from the command line. And then they come with C and C++ libraries, and there are a lot of wrappers for those libraries in other languages. So you got PHPMagick and RMagick. And the problem with Python is, I think when I started looking into this, there were like 6 Python wrappers. And somebody would start one up, and they would work on it really hard for a while, and then they would abandon it. So there's just abandonware all over the place. And with a lot of them, you actually have to find the right version of Imagemagick to use them. If you install the latest Imagemagick and grab one of these interfaces from 3 years ago, things don't work. So real quick, I'm just going to look at one of these because this is some code from Wand, and it is probably the nicest thing you'll actually see in terms of any of the little code snippets for this whole talk. Very Pythonic, it's very easy to use. In some cases, I think it's actually even simpler than some similar calls from the Python imaging library. So all we're doing here, we're grabbing a TIFF file, and then we're going to convert it twice, once into a JPEG at its actual size, and once into a very small thumbnail image. Let's see where I am. Oh, no. Oh, yeah, I'm sorry. I remember why that happens now. It's just a warning error. Basically, that's falling out of TIFFlib, and it always does that when there's a weird tag that it does not understand in the format. TIFF is very extensible. It has this large meta system and system to add even extra real data into it. So basically, it's warning that there's a tag in there that's custom that the TIFF library does not know about. I'm just going to go look at those real quick so we can see actually we did make them. So we have a small JPEG and a little thumbnail. That unfortunately is about as good as it gets. PGmagic is actually one of the older libraries that I talked about that interfaces to Imagemagick. It also, in theory, is a good interface into something called Graphicsmagick. Now, Graphicsmagick actually started out as a fork of Imagemagick in about 2002. And it's diverged a little bit. The APIs are no longer identical, and the functions are no longer identical. Graphicsmagick actually tends to be faster and with a lower memory footprint. And we're doing kind of trivial examples here, but that retailer I mentioned earlier, where we converted the catalog, the back catalog of images, they do things called Duratranses. If you ever walk into a retail store and all the giant stuff is hanging from the ceiling. So basically those are digitally photographed, or they're scanned from negatives at about 400 pixels per inch. And they're usually somewhere around 40 by 50 in size. I mean, the actual file dimensions inches. So, and they store these as uncompressed TIFFs. You end up with a single image file that's over 1 gigabyte. These aren't like what come out of your Canon camera. So when we're doing stuff like that for real, that extra speed and low memory footprint is really important. Also, Imagemagick just tends to be a little buggier, to be honest about it. A lot of times it'll suddenly just puke and not convert something. The problem with this is that I've only actually been able to actually get the whole PGmagick GraphicsMagick stack working on one machine. When I started messing around with this, when I was laid off, I had a little Ubuntu box, and I got it to work. I've been trying for about a week now. You need to use Boost and work out the dependencies, and you need the right version of C. And on the shiny Mac, which I have for work, which I mostly use as a giant terminal to get into other boxes, I just have not been able to get that one to work whatsoever. And so that's why I kind of say you kind of get beyond the pale really quick. These things sound really great, and then it turns out that it's a nightmare to actually get them up and running. Oh, I didn't want to quite do that. Sorry, first time, guys. You're dealing with a virgin. And then this is another interface that also goes to GraphicsMagick. And this is, in theory, a very, very thin wrapper around the GraphicsMagick's C++ interface. And it uses C types, and you build it with a generator file that wraps all the header files. And the problem is the header files for GraphicsMagick are really kind of messy. And this is the part where I wish I was a fire-breathing, pointer-hurling sea god, which I'm not, because I could probably dive in and straighten some of it out. But basically, a lot of times you get results like this, and I'll drop in and show you this one. This is the code for that, and first you'll notice it's a little uglier than the old code, because basically, like I said, it's a very, very thin wrapper over the low-level interface. The problem is that this GMwrap should expose all the objects that exist in that interface once you've built it. And oftentimes it just seems to fall down. I'll actually run this example here real quick. Oh, and it actually worked this time. I am amazed. Oh, no, you know what? That's because I went to the wrong one. I didn't go to the broken one. I went to the good one by force of habit. Now I can't type. Nope. Come on, Brian. Help. What did I do? Oh, I didn't close a backtick, but I can't find it. There we go. Yeah. Okay, we're finally in the right place. And there we go. Get an attribute error on module object has no attribute set image format. So this is kind of stuff that I was running into trying to sort of sort through this stuff. And basically, if you go back and look at the documentation for GraphicsMagick, you can clearly see that does exist. There is a set image format call there, but you just can't seem to get to it once you've built this wrapper in Python. And like I said, I'm sure if I knew a little bit more C, I could probably, after I've done the generation, dive into the code and patch it. Okay. So basically, as it turns out, Subprocess is your friend. That's just really what you end up doing to get all this stuff to work. As I mentioned earlier, both Imagemagick and GraphicsMagick have a very comprehensive command line interface, and just the best thing to do is to just use it and wrap it inside subprocess calls in Python. And it actually turns out, too, that that makes your life easier in terms of this being a little bit more portable. Like I said, sometimes the libraries are really sensitive to versioning issues, so if you write the code and it's working here, and then you move it and you think, you've got everything, it seems like installed and working, Imagemagick is working, everything's happy, on this new system, and you move the Python code over and something breaks, and then you're installing packages from source to get everything straightened back out again. The command line interface is just built and it works when you install these packages anywhere, and you can just go ahead and use it. So this is the one I accidentally ran earlier, and just nothing fancy whatsoever. Basically, GM convert is the call for GraphicsMagick. And an interesting thing about the command line stuff for those, if you ever start doing this, is that Imagemagick has a bunch of tools, their command line tools. And to make it easy for everybody to remember how the GraphicsMagick ones work and have them both installed in the same system, GraphicsMagick built a single tool, GM, and the first argument to it is the name of the Imagemagick command line tools. So if you were using Imagemagick, you would just get rid of the GM and it would work. If you want to use GraphicsMagick, you stick the GM back in. And that's all we're doing here. We're calling convert, and we're feeding it a TIFF file, and we're cranking out a JPEG, and then we do it again, and we make a thumbnail, which I accidentally already did, so. Oops. I'm just oh, ahead of myself. So I wanted to look at a couple other things here real quickly. I talked a little bit about profiling issues. So this is just a little bit of code there that wraps those GM calls again, and I just stuck it in a little function, and this time we're actually going to insert a profile, and we're going to run the same file twice, and we're going to use two different printing profiles, one for a really junky newspaper print and the other for an actually fairly decent paper used in Europe to print like glossy magazines. If we go in here, and there are the two files that I generated back out from the input TIFF. And I'm going to drop them into Photoshop just because it handles dealing with profiles a little bit. You can see that's pretty dark and ugly compared to, I'll just pop up the original real quick. But if you notice, if you bounce between them, they're actually subtly different. So if you were to just take that the way it is and output it on the paper without doing some color correction, you'd get this dark and ugly look. But you notice that the profile is actually, when it's showing you how ugly it's going to be, it's showing it differently depending on which actual press that you pick. And then I'm going to run both of these real quick. They're basically here we're going to grab an encapsulated PostScript file and turn it into a TIFF file. And in one of these, I've actually turned on the LZW compression. which once again is really, really simple. You just pass compress and the name of the compression. And if that output format supports that compression, you get it. One of the important things about the command line is a lot of times this stuff from the command line does not error. So with some of these, and I believe this is one of them, if you pass compress LZW to something that doesn't support it, you don't necessarily get an error. You just get the output without the compression. So it's something to watch out for if you're messing around with this stuff. And you see the two TIFF files are actually slightly different sizes. LZW actually really is not, it's lossless. That's why all the publishers like it. But to be honest about it, it would be better to create the image raw and just wrap it in gzip as far as saving storage space and open and stream it that way. But once again, these folks are fairly conservative, so they don't want to hear things like that. Okay. And then the last thing I want to talk about a little bit is ffmpeg. Traditionally, the print guys don't do a lot of video stuff. There are a couple other applications that do similar kind of archiving and cataloging for video. But enough ad agencies do a little of both that some of the software that I deal with also does some minimal image archiving. Typically what it does is it'll take the movie and it will either generate a small streaming format like something you'd see on YouTube, or it will create basically keyframe thumbnails like you would see if you've ever messed around on sites we won't talk about, and you go underneath the video and you get little frames popping up. I have some sample code here that does that. And once again, the command line is your friend. And this is a little tricky, actually. This is actually one of the more fun things that I figured out doing this, which is there's no good way from ffmpeg from the command line to actually figure out how long the video is. There's no sort of sane way. But anytime you make an error, in addition to the error message, it throws all the meta information on the video back into standard error. So what you can do is deliberately cause it to error and then parse standard error to find how long the thing is. Which is all what we're doing here. We're actually calling ffmpeg in a way that we would normally read an input and generate an output. Like say if we're going to take the MP4 and create an FLV file, and we don't actually give it an output. And so this first subprocess popen call here will actually fail. But in out where you see out p standard error read, I can actually grab that information, and then we just parse through it to get the information about the duration of the video. So this section right down in here. And we're just doing that because basically we're just going to slice through the video and grab a frame. And in this particular case, we're going to grab 9 frames. So no matter how long the video is, whether it's 1 minute or 3 hours, you get 9 frames evenly spaced out through it by doing this. And what we're actually doing is we're grabbing those frames and we're going to save them as JPEGs. And then just as a little bonus, since I said you should use the PIL whenever you can, down at the bottom we're going to actually use the PIL to resize those. So you'll actually get 2. You'll get the main JPEG and the little thumbnail. I'm not nervous or anything, I swear. So I'll just, any questions so far, because this is actually going to sort of run for a little bit, and I want to let it run at least long enough to generate a couple of frames out. while sitting here cranking. Okay, and there you can see it started. The actual video I was running was from PyCon Atlanta. And we started to dump some frames out from it. No, it doesn't take as long as it does to play the video to run through it. I mean, if you were doing this for real, this is one of those things where, if I were trying to architect something like this for real, you'd basically want to use some kind of message queuing system and sort of queue these things up and have a farm cranking through these for you, because the videos can take a long time. Even the images can take a long time when they're large, and you tend to get them in big batches. For the kind of applications that we build, sometimes you'll have like a web upload thing like you'd see for Flickr or Facebook where you're uploading an image into it, but probably 80 or 90% come when they're finished doing whatever it is that they need to do to get this thing printed, and then they drop, 500 large image files on there at one time, and then 10 minutes later they're wondering why they can't go back into the web application and find them. So yeah, basically, and I think that's another thing that makes just dealing with the process is nice. You can pretty easily create some workers that wrap subprocess and stick some things in a message queue and run as many as your system can stand and pull them back out again, and it just kind of separates everything out nicely. Yeah, because I mean, this is only about a 45-minute video, and you can see the amount of time it's taken. It will not take 45 minutes, but it will take some time to crank through and generate all these. Any other questions? I apologize that it's short, but I just kind of ran out of time to get some stuff done that I wanted to do.
When you ran into issues with PIL, did you have any communication with the PIL project?
No. I mean, because with PIL, it wasn't so much that, hey, this is broken. It's more like, hey, it doesn't do this obscure thing that I need it to do. The issues where things were broken tended to be for various things that people had written over time to wrap Graphicsmagick and Imagemagick and ffmpeg. That was another one. There is a Pi ffmpeg, and somebody started cranking away on it a couple years ago. There was a big sort of fork in the ffmpeg community, and a bunch of stuff went on there, and it won out. And after it was kind of clear where that was going, somebody got all excited and started working on a Python interface to it, and then they just quit. The last commit was like in January of 2011. And you can sort of get it to work if you back up to the ffmpeg that exists back then. But because I'm dealing with a Mac, and I'd rather not be for this kind of presentation, but I just use brew. So if you just do brew install ffmpeg, you get a much later version, and none of that stuff will actually work. So like I said, for most of this, just wrapping the command line actually seems to be the thing to do. Anything else? Go ahead. Yeah. Yeah, no, it chunks it out. So basically it's chunking it in memory. So no, we don't get a lot of disk use for that. And that's the other truth of the matter is for some of the larger files, I've not actually done timing tests, but I ought to, because I suspect for these days for a lot of the large files, with the speed of storage and how much storage we have, that it would be quicker to just eat the storage costs and stream things out the disk than it would be to compress them in and out again. It's really not a terribly efficient compression algorithm in a number of ways. You only get on like images probably about on a good day maybe like 50% compression. You know, so if the thing is 20 megs on a good day, really good, you'll get 10 meg out. 15 would be more common. And it actually has a worst case where it will slightly blow up. So you can throw it a 20 meg file and occasionally get a 21 meg out as your compressed file format. Anything else? Okay, well, hey, thanks for putting up with a very nervous first timer. Have a good day.